Now, let's talk about these registrations. So first, SIP and H.323, these are the two communication protocols that are commonly used in the collaboration solutions that we are all talking about now. So Expressway supports both these protocols for audio and video calls. Yeah. So first, let's talk about SIP here. So for SIP endpoints, so SIP, first of all, this was introduced as an open standard. This is an industry standard protocol now, and we're slowly moving completely to SIP. So it's a very important protocol for endpoint, for signaling, and so on. So IETF is Internet Engineering Task Force. They have created and developed this protocol, and it's still emerging. So you very commonly see changes to it nowadays. So by design, SIP requires the use of SIP server to function as the call control device for all SIP enabled endpoint activities. The SIP server performs functions like registrar and proxy functions, and SIP server here in our case is the Expressway. Yeah, so this act as a SIP server for SIP endpoints, which requires to perform functions like the proxy functions and registrar functions for registrations and call services. So Expressway maintains a table that is composed of information like URI, because SIP endpoints use the URI format, and their IP addresses. Yeah, so this is a table that is maintained in the Expressway, in which it has the information of the URI addresses and IP addresses which are taken from the devices at the time of registration. Yeah. SIP uses URI addresses, uniform resource identifier addresses, for communication between the SIP devices. The SIP URI is built from a user portion. For example, you can see right here, jdo@cisco.com. Yeah, this is one example where we have a user portion, jdo, and we have a host portion, which is cisco.com. Yeah, or we can call it a domain. That is called a URI format. So because the SIP URI must contain the domain name, the domain must exist within the Expressway for these devices to be registered. So when we configure Expressway to be able to register the SIP endpoints, we have to add a domain name here. So you might have seen in the configuration tab, there was an option to add domain. So there you must have add the domain name here, like cisco.com, for the SIP endpoints to register. So that is a prerequisite. Yeah, so we will see that. So for Expressway C, to be able to successfully register those, we have to add the domain. SIP by itself does not contain media related information like what codecs is to be used or what IP address the media should be sent. There is a protocol called SDP. This is about how SIP functions. There is a SDP protocol called Session Description Protocol. This is the one that takes care of the information of the call details, like what protocols are used, what IP is being used, yeah, what media related information is used. All that is exchanged within the SDP information. Yeah? So we will see that here. Okay. Not here. Okay. So for SIP endpoints to register, this is what the registration process is. So we discussed about the registration process of IP phones. Same is the case for the SIP endpoints, telepresence endpoints, and Expressway communication for the SIP registration here. So first thing is it obtains IP, then it loads the local firmware, then it will get the voice VLAN information through CDP. Then it will get IP address through DHCP, SIP setting configured locally on the endpoint. Now there's a difference from how the IP phones get registered on the CUCM and how it gets registered on the Expressway. A lot of configuration in case of Expressway is to be done on the endpoint itself also. So you have to manually configure some configuration on endpoint like IP address, SIP mode, or endpoint mode, all those. So in case of SIP settings have to be configured on the local endpoint. Then it gets a registration request sent to the Expressway, and the Expressway acknowledge and register it. So this is the registration process. So once the registration process has occurred, then there are some messages exchanged at the time of the communication between SIP endpoints. So let's suppose we have two SIP endpoints communicating to one another via the Expressway. See here, so we have one endpoint here, one other endpoint here. So within the SIP communication, there are different types of messages exchanged, like invite, trying, ringing, okay message. Then there is audio video exchange through the or RTP and RTCP ports, which are open for the communication. Then acknowledgement is shared, and when the call is terminated, then terminated messages by messages are shared. So all those information messages are exchanged between the two parties via the expressway. So within the invite message, there is something called SDP, session description protocol, which takes care of the media related information, codec types, all those exchange and negotiation takes place here. So this works as the communication protocol and the description protocol to maintain the database and the description of the call, of the active call. Yeah. So when the endpoint is registered, a different process can be used for call processing. There are two ways that a SIP call can be processed. One is called early offer in case of SIP, and the second one is delayed offer. If early offer is used, then this is the type of messages exchanged. Just the difference in early and delayed offer will be that in early offer, the SDP exchange happens within the invite message. The first message itself, it shares its codec information, session description details, media information, all that. Whereas in delayed offer, it sends it in the OK message here. That is the delayed offer. So these are the two types of call processing ways in case of SIP. So in early offer, this is the method which is used in Expressway series, and it includes SDP in the initial SIP invite, whereas the late offer or delayed offer method does not include SDP in the invite, but it is after the trying message that you can see here, like trying and ringing, and after that it progresses with the SDP in the acknowledgement. All right. So next is H.323 standard. H.323 is an ITU standard, International Telecommunications Union. They developed and maintained H.323 standard. It's a bit old protocol and outdated now. So for packet switch communication, we used the H.323 standard protocol, and H.323 use many substandards. So H.323 itself is not a protocol. It is a framework in which there are different protocols which are used. So you'll see like H250, 225, or uh, different protocols that we will come across here, which all comprise of the HT23 framework. Yeah, so it's a framework. And HT23 has all these substandards which are used. So when a device is supporting HT23, it should be enabled with HT23 compliance and should be enabled with the device capabilities that is from the device endpoint. And then a gatekeeper can be used to enable the dialing between the devices using the names HT23 ID or E.164 standard numbers. So in this case, that would be Expressway. So Expressway, it is recommended that you register HT23 enabled devices to Expressway for many reasons, like including dialing by name or numbers. Not all gatekeepers supports that, but Expressway does, like dialing by name or number. We can configure security, call control, interoperability with third-party applications and servers, registration, administration, status, or RAS. This is a message exchange type, like we discussed messages exchange between SIP. There is something called RAS in HT23. So there is registration. RAS stands for registration, administration, or admission, yeah, and status. Yeah, this is what it is. So administration, registration, admission, and status, or RAS messages, are the messages that are sent between the endpoint and the gatekeeper and are used for both registration as well as call setup. Yeah, so these are the information exchanged. There are messages types like registration request, then there is registration confirm or registration reject based on the status that will happen. So to register an HT23 enabled device to Expressway, you have to configure the device with either E.164 standard or H.323 ID or both with an IP address of Expressway that must be manually configured on the endpoint. On Expressway, you have to enable H.323 mode, which we just saw, just have to enable H.322 on to accept the registration request. Otherwise, it will not accept the registration request. That is the case where you might get a registration reject message from the Expressway. Yeah, so these are different messages exchanged between the endpoints, H.323 endpoints, like we saw in the case of SIP. And then there is call setup, which is same as the call setup in the SIP registration. There is negotiation process where audio and video capabilities are exchanged. Once the call is answered, the RTP, RTCP is a protocol that makes the real-time communication. That is the same, just some admission request, messages, status and registration messages sent are a bit different. All right. Then there are some call routing modes in H.323. One is direct mode, other is non-routed mode. Then we have routed mode, we have media routed mode. So let's talk about these one by one. First is the direct mode in which you must use an IP address. H.323 call setup without Expressway has a gatekeeper. That is the simplest form of call setup because call setup does not involve Expressway. The call setup is established directly between the endpoints, and this method allows dialing an IP address only. So there's no option to dial an endpoint alias in case of H.323, which is the case in SIP or E.164 number. So there is no way to translate these into IP. So you have to use the IP addresses in the direct mode. Then there is a non-routed mode. In non-routed mode, it allows only registration, administration, and status RAS messaging to be routed through the gatekeeper. And because registration, administration, and status, this is communication with the gatekeeper. The call setup would require some negotiation. There would be H.245. This is used as a negotiation protocol for negotiation process. There would be media exchange, which is done directly between the source and the destination. So you can find these Q391 for media exchange, H.245 for negotiation process, and so on. And then audio video communication takes place in case of non-routed mode. Then we have routed mode. In called routed mode, it requires all the TCP signaling to route through the Expressway C, including the RAS messages, H.225, which is also called Q931 protocol, H.245 for negotiation. So these are all protocols that comprise of the H.323 framework. Now all these protocols are used in the routed mode to route the Expressway C call setup and requests. So, however, the media still routes directly between the source and destination in case of the communication between the endpoints. So between the source and destination endpoints. But in this mode, the Expressway always know the status of the call. So everything goes through the Expressway. That is a routed mode. So media routed mode requires all the signaling and media to route through Expressway C, which is not the case in direct or non-routed. Then we have media routed mode. In media routed mode, this is used whenever a change is needed, either in signaling or media. So usually this mode is used during the types of traversal calls, like firewall traversal or calls between H.323 and SIP, where interworking is being used, or calls between IPv4 and IPv6 is used, or dual interface calls, like calls with the Expressway E devices. So in those cases, media routed mode is used. Yeah, like in the traversal. So for all these purposes, these are the different modes based on the different types of communication. Okay. Then we have interworking in Cisco Expressway series. So we just discussed that so that we can enable interworking to enable two different protocol endpoints. SIP and H.323 to be able to communicate to one another. Yeah, so for example, here we can see this diagram shows a SIP and H.323 endpoint making call, like here, making call with one another. And with Expressway feature of interworking, we can make that successful. Then we can have different types of calls like SIP to H.323, SIP to SIP. We can have IPv4 to IPv6. All these type of interworking is enabled and can be enabled in Expressway. So interworking is all about more than translating SIP and H.323. We can also have functions like IPv4 to IPv6 or even to third-party applications and endpoints. Then we have signaling and media, which is being used. We just discussed about some modes. So when Expressway interworks between these protocols, all the signaling passes through the Expressway in a normal way, except that it is translated into other protocol and passed on to the receiving device. So with an interworked call where you have SIP and H.323, two different endpoints and the signaling media going through the Expressway, there can be encryption mechanism which is identical for media between the protocols. For encryption, we have another protocol of the H.323 framework. Let me mention that here. That is H.264. Now, this is used for encryption mechanism between these protocols to endpoints, both SIP and H.323 communication, and both supports this. The payload around the media is different, and so Expressway has to adjust the media payload before it passes on to the receiving device. So all those functions are performed for translating and all that by Expressway. So with interworking of media, you should not be confused with the media processing of the conference calls, like with the in case of meeting servers. We will get into that. Then Expressway also does not do the transcode or translating of the media. That is a separate altogether, a different function for different devices, transcoders. It just simply adjusts the payload and then passes it on to the other device for performing the interworking. So these are the various options in interworking that we just went through. So interworking off. In Expressway, there are three possible settings that can define how it behaves when interworking is required. The off setting means that interworking will not happen in this Expressway device. When Expressway device identifies the two devices are using different protocols, if interworking is set to off, the Expressway device will then not interwork that call. However, if there is Expressway device and the call routed when interworking is allowed, then the call will be functional and will work. So that is where interworking on would be required. So in this case, when interworking is on, all the calls between SIP and H.323 endpoints registered to Expressway or CUCM within the network or any other gatekeeper all can communicate to one another. Whereas registered only just limits this capability and says that only the call communication will be allowed through Expressway C between a SIP and H.323 endpoints if at least one of the devices is registered to the Expressway. So in this case, like this SIP device and this H.323 will not be able to communicate as they are registered on CUCM and Gatekeeper. But SIP H.323 devices registered on the Expressway C can communicate with other the SIP and H.323 endpoints. Yeah, so at least one device has to be registered with Expressway for registered only, whereas in the case of on, it will be able to make communication with all. So like a SIP to H.323 device on CUCM and Gatekeeper, SIP and SIP device, SIP or H.323 device, H.323 and H.323 or H.323 to SIP. Okay, so this is how then the interworking works here. So we have, let's suppose that interworking on the Expressway C, so we can make communication between the SIP and H.323 devices. It can send registration request, registered only request to Expressway E, and then the other devices registered on Expressway E with SIP and H.323 will also be able to communicate with one another and to the other devices on the other product of Expressway. So this is all about interworking that is required. Then we talked about some SIP early and delayed offer, in which SIP early offer has SDP, session description protocol for media negotiation, codec, and call details information for a call setup within the SIP invite, whereas in a late offer, or it's also called delayed offer, it is sent in the acknowledgement and not in the invite message. Similarly, SIP to H.323 calls. For this, the significant challenge for interworking a call between these is that the H.323 signaling capability set is exchanged by the protocol H.245, which is a negotiation protocol. It only is exchanged after a call has been answered, which is not the case in SIP early offers, especially. So even if the call is answered before that, it is responsible to maintain SDP information, yeah, the session description information. But in case of HT232 SIP, because of the compatibility issue, what happens is only this capability set is exchanged after the call is answered, so that once the Expressway has done the transforms between these two and made the interworking possible, and the call is being connected between the two different endpoints, then the capability set will be exchanged through a protocol H.245. Same is the case of HT232 SIP. So for a call that is initiated on HT23. Now, in that case, what would be the case? You will rely on the SIP late offer capability. So because in HT23 we do not have a initial uh, negotiation protocol to work. So if the communication starts with the HT23, then from the SIP end it works as a delayed offer. So again, in the acknowledgement message from the SIP, it will be sharing the SDP.